Hello everybody and welcome to another tech video, and in this video I want to look at some of what I found to be disturbing noises in my lab. And now in the far past we might have been concerned about hearing hum coming from the power grid, like 50 Hz or 60 Hz type of hum. But in recent years all our devices got like these modern switch power supplies, and we might be bothered actually by other types of noise than hum or ventilator noise from our devices. And recently in my lab I had the feeling there was at least one source that was creating very annoying types of noise, audible noise. And so I decided to go and further explore that. Who were these devices and what did the noise exactly look like? So when you wanted to analyze such noise, then you could start by using a spectrum analyzer or a oscilloscope with FFT function to try to get hold of the spectral components, the frequency components. Now I did some attempts like that, but unfortunately these attempts were very unsuccessful. Why so? Because actually the acquisition time both on the spectrum analyzer and the oscilloscope were very poor, up to tenths of seconds to draw a screen if we're looking at those frequency ranges. The spectrum analyzer mine has a specification that it starts almost from 5 kHz, so that would actually do because I'm more interested in higher frequencies, 10 to 20 kHz or so, but it was way too slow. So I actually moved to a setup which is much closer to what is used by people recording audio. So let's see what we got here. First disconnecting this. So I got a microphone here. This is a Rode microphone coming from Australia, an NTG4 Plus microphone. So this is a condenser based microphone sensitive to high frequencies. It is a long throw microphone. It is I think super cardioid, so you can really use it to pinpoint particular sources of noise. It's very directional, and that makes it an interesting microphone for such purposes. Then I'm using a mic preamplifier. This is a mix spray by sound devices. You might have seen these people doing audio recording, and it's a brand also popular in the movie industry. I'm using it for phantom power to power my microphone here, and I'm using it as a preamplifier and a ADC digitizer for my computer. On the mix spray I selected an appropriate gain, and I also activated a low pass filter of approximately 40 Hz that brings down a little bit the possible hum and other signals I might have in the room here that I'm not interested in. And finally I bring that to a laptop computer over here, and on this computer I'm running Logic software. So that's audio recording software, multiple track audio recording software, and let me log into my computer. So within Logic here I'm using the equalizer screen, and that actually shows a nice display of spectral components. So actually you see me talking now. I'll sing a note. Now I'm not here to sing, but we basically see my voice popping up. So when I will be quiet, we'll still be seeing a little bit of things around the room. That might be a little bit noise coming here, hum from appliances here in my living room, 50 Hz. There might be a car driving by on the street, and there's all type of background noise, but a fairly low. So let me be quiet for 1 second, and we're going to see what is like the silence here. Yeah, so we see mostly something around 50 Hz, and it was just a car driving by, and we saw that also in the screen. So let's now start our measurement, and I'm going to look at two culprits that I've identified as the possible sources of noise in my lab. And the first one is here. It's a GPS disciplined oscillator of 10 megahertz. I think quite a few of you that are looking this type of videos have something like this at home. And it's actually not the device itself which I suspect of making noise, but it's the power supply. This is not the power supply that came with it. The power supply that came with it broke down. I replaced it by something I had lying around, and this is a power supply that once was shipped with a a hard disk. This is from a Mac store, one-touch hard disk. And I decided to use it for this GPS disciplined oscillator. Until recently, with dissatisfaction, until I started to suspect it of making noise. So what I'm going to do, I'm actually going to power it up, and then we're going to look at the spectral components that we see on the screen here. So I'm going to try to be relatively silent and then power this thing up. And yes, there we go. We can very clearly see that. There is a high tone which is upward from 10 kilohertz that is clearly creating a tone. And for me, this is an audible tone. I do hear this all the time when it's on in the lab. I can try to identify exactly where it is by just activating one of the equalizers here, the parametric equalizer, and just move around the central frequency for that. And just look at where the dot goes. So that is approximately 14.2 kilohertz. I find that noise very annoying. I mean, whether you will be bothered by such a noise or not, your mileage might vary, your ears might not be sensitive anymore to that frequency, or otherwise you might not be so bothered. But for quite a few people, and that includes me, this is clearly audible, and this is rather an awful noise. And the difficulty is to pinpoint it, where it actually comes from, because at some point in time you got dozens of power adapters and devices having around in the lab, and finding out which one is actually causing the trouble, because it's very hard with the ear really to identify the direction of such high-pitched sound at that frequency. This microphone is actually doing a much better job at that. Okay, so welcome back to the second measurement I'm going to do here, and I took a GW Instack power meter. Now, some of you might have seen this. I've reviewed this in one of my previous videos, and also noted in this video that I was annoyed by a high-pitched sound coming from this particular device. So let us see if we can, in a similar type of setup, recognize that as well. So everything is set up like in the previous measurement. We're going to look at the spectrum analyzer screen, the audio spectrum analyzer screen to 20 kilohertz. So I'm going to be quiet for a second, and then I will be turning this unit on. Yes, and there we got it. We see a fair amount of high frequency signals coming in here between the 10 and the 20 kilohertz. I could try to look again a little bit what are the main components that we're seeing there. 15 kilohertz, fairly close to what people used to hear when we were using old PAL TV sets at home, here in Europe at least. They would give a slightly over 50 kilohertz tone, and if you had good ears you would hear that. Yeah, I see some couple of tones at 11 kilohertz as well. And I was doing these experiments yesterday. After the unit was on, I also saw a little bit of noise around 6 kilohertz or so. That's probably audible to almost everybody here. Now again, I'll be silent for a second and turning the unit off, and then we should see the noise, the high-pitched noise, disappearing. And yes, we see all the noise is gone again. So we've clearly found two devices here in the lab that were causing the annoying noise that I was experiencing the last couple of weeks, at least in my lab. Now the power supply for the GPS DSO, GPS DO, I mean that simply I could find another one for it. This is a little bit more problematic because I might need to see with the maker of the unit if this is within specs. It's certainly pretty annoying. I'm not having this device on when I'm working on anything else in the lab, only when I actually need it or so. So yeah, so this brings me to the end of the video. I hope you found it interesting, and it might also inspire you, if you're bothered by having noises in the lab, to try to look around a little bit and try to pinpoint what is causing that noise and what is the nature of the noise. Of course, we haven't been measuring here the absolute levels of noise. You can do that as well, and I did that in my lab a couple of times. Then we're talking mostly about devices that have ventilators and that make like other types of noise, and then we will be using a dB meter. And in recent days actually you have pretty decent apps on mobile phones that come fairly close to what a dB meter would tell you, with the right weighting and so on. Of course, today we did another type of experiment, and we'll be mainly interested in the spectral distribution, the kind of tones that we're seeing. But we don't have a calibrated setup here, and we're not measuring like the absolute energy that is present in any of these tones. Anyway, I hope that you like this video, and perhaps see you next time.